Welcome back. Today I would like to explain the analysis of common collector amplifier. In previous class we have seen common emitter amplifier analysis with emitter resistor and without emitter resistor. Now I would like to explain the common collector amplifier analysis. For that, let us see the diagram of common collector amplifier. Okay, this is the common collector amplifier. Common collector means the input is at the base of the transistor and output is taken from the emitter of the transistor like this. Okay, so for the analysis, what you have to do, you need to convert the given circuit into small signal equivalent circuit. Okay, so first I am converting or representing transistor in the equivalent model, including the R0, including the early effect, that is between base and emitter you have R5 resistor, between collector and emitter you have one current source with the value beta IB and a parallel resistor R0. Okay, and collector terminal at the ground potential because it is a CC configuration, and output is from the emitter, and from the output from the emitter to ground there is RE resistor. That means output is the drop across RE resistor. Since the DC sources comes to ground, therefore R1 comes in parallel with R2, and as usual at the input side Vs in series with Rs. For the simplicity, this circuit is converted in the form like this. Both are same circuits. For our convenient purpose, I rearranged the different components like this. Okay. From this, the input resistance Ri is, first of all I would like to derive the input impedance or resistance. That is, looking at this point, it is R1 parallel R2 parallel to RIB. This is the RIB resistor where this is the location where RIB. So input resistance is R1 parallel R2 parallel RIB. Right? Input resistance Ri is R1 parallel R2 parallel RIB. But where RIB is, for RIB, let us write Kvl equation in the base emitter loop. In the base emitter loop, if we take the Kvl equation, that is Vin equal to, is it Vin? The Kvl equation between this one is Vin equal to, suppose IB into R pi plus I naught into the parallel connection of R0 and RB, right? IB into R pi plus the drop across this parallel connection, that is I0 into R0 plus RE, where what is I0? I0 is sum of two currents, one is IB and another one is beta IB. That is I0 is 1 plus beta times of IB, right? So that here I represented. So here in this equation I0 is taken as common, therefore R pi plus 1 plus beta into R0 parallel RE, right? This is Vin. Therefore RIB is, RIB is Vin divided by IB. RIB is Vin divided by IB. Now substitute Vin value, therefore IB cancel, hence RIB is R pi plus 1 plus beta into R0 parallel RE. Clear? See this one. Input resistance is a parallel connection of R1 parallel R2 parallel RIB, and RIB is derived like that. Its value become R pi plus 1 plus beta times of R0 parallel RE. Okay. Then the voltage gain is the voltage gain is defined as V0 divided by Vs. The voltage gain is defined as V0 divided by Vs. Okay, V0 is, what is V0? The drop across parallel connection of R0 and Re. Okay, the drop across parallel connection of R0 and Re is the V0. Okay, that is this equivalent resistance into I0 gives output voltage. Okay, therefore the output voltage is, you can write it as I0 into R0 parallel Re. But I0 is a sum of two currents IB and beta IB. Therefore, IB of 1 plus beta into R0 parallel Re is the V0 voltage, the output voltage, right? Now substitute IB value already derived previously, and V in terms of Vs is, in terms of Vs you can write it as Ri divided by Ri plus Rs into Vs. So if you substitute all those, therefore the voltage gain we can obtain is 1 plus beta times 1 plus beta into R0 parallel Re divided by R pi plus 1 plus beta into R0 parallel Re into Ri by Ri plus Rs. Like that we can get the voltage equation. Okay, clear? Next, output resistance. For output resistance, Vs becomes 0, and Vx is the test voltage is connected at the output. But here, when Vs is 0, the control voltage V pi is not equal to 0, and it is a function of the Vx. Therefore, V pi is minus Vx. Hence, at the output node, you can write the KCL is Ix at the output node. Ix is one current, incoming current. Another incoming current is Gm V pi. Therefore, Ix plus Gm V pi equal to Vx divided by Re plus Vx divided by small r naught plus Vx divided by R pi, where what happens, this R1 parallel R2. Since it is a short circuited, this one also acts as a short circuit. It is parallel to short circuit means R1 parallel R2 also acts as a short circuit. That's why that is neglected, right? And V pi is minus Vx. Therefore, this equation can be written as like this. That is Ix by Vx equal to inverse of the output resistance equal to Gm plus 1 by Re plus 1 by small r naught plus 1 by R pi. Therefore, R naught is a parallel connection of 1 by Gm, Re, small r naught and R pi. Like that, the output resistance is derived for the emitter follower or common collector amplifier. Similarly, the current gain is derived as, the current gain means, as per the from the circuit, the current gain is IE divided by II. From the input, the base current, IB is derived like II into R1 parallel R2 divided by R1 parallel R2 plus RIB. Okay, from the fundamental relations, at the input circuit, the IB is derived like this. Similarly, at the output, okay, we derived this one is like this, and I naught equal to 1 plus beta times of IB, and IB already we derived right now. If you substitute this one, the I naught becomes like this, and from the output, IE equal to, I naught into R naught divided by R naught plus Re. Now using these two equations, or you can substitute instead of I naught W equation. If you substitute W equation, the current gain AI equal to IE divided by small II divided by II equal to 1 plus beta into R0 parallel R2 divided by R1 parallel R2 plus RIB into R0 divided by R0 plus R. So like that the current gain is derived in the emitter follower or common collector amplifier, right? Okay, thank you. In the next class you can see common base amplifier analysis. Same in any amplifier case, you have to derive voltage gain, input impedance, output impedance. Since it is a common collector, in common collector case current gain is very high, that's why we derived that one. Okay, thank you.